precision farming or the sensors or automations. So I have some experience in this area, so I will try to share with you all this. So,
Okay, I would like to add, one of the project almost cost is about 2000 lakhs. So sir was mentioning about projects. So there are so many projects. If you will check his biodata, there are almost 35 or 40 projects. So many awards that it will take me an hour to scroll down. So sir is the most relevant person in the precision agriculture, to be very frank, because you will not find any other person with so much of experience, so much of intellect caliber like our Professor Manjeet Singh sir.
thank you.
So thank you very much, sir, for accepting our invitation to be a part of this training program. And I would like to request you to please go ahead.
Okay.
I hope that our participants will get benefited from this.
Thank you.
Thank you.
Thank you, Dr. Muzamil, so for the nice introduction. So I will start.
Sir, अगर हम बैठ के ही करना चाहिए?
Okay, so who will start up? So as the topic given to me was sensors and automation in agriculture, but when I was traveling yesterday from Ludhiana to this place, so I have seen on the way that there is need of mechanization also. We cannot directly go to the sensors and automations. This is required, but still here in J&K, mechanization is still required. So that's why I added one more word here at the front of this, mechanization. Okay. So I will first discuss mechanization, then we will discuss sensor and automation. Okay. So next. So this, my first slide is that how evolution of agriculture is going on. So first there was animate farming. I think in J&K still animate farming, and some way it's moving towards mechanized farming. So in this animate farming, what's there? Low input and low output, because there is more human and animal force, but lesser intelligence was required in this, because this is power is only given by the animals or human power. So that's why this is low input in terms of mechanization, and then similarly we are getting low output. But in now, if we discuss other parts of India like Punjab and other northern parts of this India, so we are in the second stage in mechanized farming. So in that mechanized farming, there is high input and high output, as there is more mechanical force with human intelligence, because driver is there to operate that tractor or any machinery. So that human intelligence is there and power is also there. So this is second type of agriculture. Now third is in which we are moving, or some advanced countries already moved to that is called digital or precision farming, as we are doing some projects in the university in the R&D side. So that type of third farming is digital or precision farming. So in this there is optimized input and optimized output. So mechanical force with artificial intelligence. So this word, I think now you might be familiar with this word as artificial intelligence. Earlier there was human intelligence, now it is artificial intelligence. Okay. So this is complete system. This as inputs are given to the agriculture system in terms of energy, water, air, soil, agrochemicals, machinery, labor. So all these inputs are given to this agriculture system, and then there is weather conditions, there is climate, information, management. So all these are there. So what we are getting as the output? Food, energy and materials. Except this, I say that when we get this materials or yield or produce, so there is quality of produce is also we are getting, maybe poor quality, maybe better quality, or maybe best quality. So quality of that material is also important, and as well as environment in which that agricultural system is there, that is also the output of the agriculture system. Okay. Now next. So first, as my this topic is mechanization. So what is the advantage of mechanization or farm mechanization? What we received in our case or in our states, so I'm talking of that there is increased farm production as well as productivity by 10 to 15%. By using mechanization, there is increase in the farm production as well as productivity by 10 to 15%. So this is first advantage. Second advantage is higher cropping intensity, that is by 5 to 20%. So you know what is cropping intensity? What is cropping intensity?
How much time a particular crop is grown on a particular piece of land? How the frequency of that?
Yeah. So in a 1 year, in an annual or in a single year, how many crops are taken? So as for the Punjab, this is 200%. So it means we are taking 2 crops. So what about here in J&K?
Sir, one.
Only one?
In case of paddy, and also in case of vegetables, also in fruits also, because we have limited period of 6 months for cultivation.
Yeah. So because in 6 months there is snow and all these.
Yes, sir.
So you have 100% cropping intensity, but we have 200%. But by using mechanization, we can increase by 5 to 20%. Okay. So third is saving in seeds. That is 15 to 20%, because when earlier the sowing was done broadcasting for the wheat or for the rice, for maize, there was broadcasting method was used for the sowing or seeding. But when the drills came, here what is the status? Drills are there?
Yes, sir.
There are drills
Yes.
for some crops. For which crop? See, drilling is done. Drilling, you know, drilling. Drill machine, you know, I think. Or especially farm machinery people might be knowing. So there are machines for the sowing of the crops, so that drilling or seeding is there. So by using those machines, there is saving in seeds by 15 to 20%. Okay. Then saving in fertilizer as well as chemicals, that is also in the range of 15 to 20%. Then reduction in time and labor, that is up to 20 to 30%. So there is a reduction in labor also, no? Reduction in labor as well as time. So that is in the range of 20 to 30%. These are advantages of mechanization. Okay, so next. This is given that what is the level of mechanization in other countries. So as compared to India. So if we talk about USA, so there is 6 kilowatt per hectare. So you know farm power availability or mechanization index, how it is measured? How it is measured? Farm mechanization level or this availability of farm machinery. This is taken as because at any farm there is power is used in forms of human, in forms of animal, in terms of any engine, in terms of tractor, in terms of any motor. So any form of power is used at the farm. So the power of that source is added and then divided by the area covered by that machine. So that is that unit is kilowatt per hectare. Okay. So it means in per hectare or per unit of area, how much power is used, that is called mechanization index. Clear? So in this USA, this is 6 kilowatt per hectare. And in Japan, it's maximum 14 kilowatt per hectare. In Korea, this is 7 kilowatt per hectare, Germany 2.4, France 2.6, and India. This is some little bit older data. So now we are at about 2.5 kilowatt per hectare. Overall, India's mechanization index is 2.5 kilowatt per hectare. Okay. So Japan is maximum, and then other countries also at the good level. But in India, this is lesser. But if in India we talk of Punjab, that is at the maximum. So that we will discuss later in later slide. Yes, next. Yeah. So this is the scenario of mechanization index in India or farm power availability in India. So tractor is 60%. Overall, if we discuss of India, so tractor power is 60%, and power tiller 1% only. Then diesel engine 14%, and then electric motor about 20%, and then animal power 3% only. Now it has been reduced, but I don't know about J&K. Any farm machinery people can tell that how much is the farm power availability or mechanization index in J&K? Do you have any data? No? Okay. So then human power is 3%. Okay. So this is, if you see that graph at the top, so this is what was the scenario 1961-62? The red one is mainly draft animal. So that was maximum. But now if you come to 2020-21, now this is tractor power is maximum. Okay. So this has been replaced, human power or animal power has been replaced by the mechanical power or tractor power. Okay. So now you come to bottom graph. In this, you can see that there is direct relationship between farm power availability and productivity, farm productivity. So if you see 2060, 61, 62, there is power availability in India was more than 0.5 or you can say 0.7 kilowatt per hectare. So then now it has been increased up to 2.5 kilowatt per hectare. Similarly, productivity in 1961-62 was less than 0.5 ton per hectare. So now it has been increased up to more than 2.5, or it is now almost 3 ton per hectare. So there is direct relationship between farm power availability as well as farm productivity. Okay. Now this figure is in India, it is 2.76 kilowatt per hectare. In Punjab, this is 4.92 kilowatt per hectare. So this is maximum in Punjab. Okay, and this is 80% more than the average of India. And if similarly productivity is also, you can say, almost double that of India. So if we say that in India this is 3 ton per hectare, so in Punjab it is more than 6 ton per hectare. Okay, so this is direct relationship between that. Now next. Yes, now we will discuss some tools which we are already using in Punjab, and here you can try. So I have taken only those equipment or instrument or machines which you can try here in also J&K. Okay, so this is very small machine. We introduced in 1985, and then some improved version in 1992, and then again improved version in 2003. So we have already this machine. So this you can see that this is very small machine, manual operated, and can be used in many crops. You have here mainly rice and maize, or any other crop. Rice and maize you have. So in that rice and maize you can try this machine for the weeding purpose. Okay. And similarly, because there is attachment of the seeding is also there. So this seeding attachment you can add, and then this can be used for the small fields. 1 acre, half acre, this can be used. Okay. Next. Yes, previous one. In this, as number of manufacturers who are manufacturing this machine, those are 100, 5, and 1. Number of manufacturers. Liaison with the Falcon, number of manufacturers. There is some confusion in this data. So you can see that there are many manufacturers manufacturing this machine, and even our university is also manufacturing this machine. Okay. So next. This is next machine, that is self-propelled power weeder. This can be used as we are using for the wide row crops like in cotton or in maize, also in orchards. So here you can try this in maize, because this maize is wide row crops. This machine can be used for the maize as well as for the orchards. You have orchards, apple orchards and any other orchards. So this machine can also be tried for the weeding or for the tilling purpose in the orchards as well as wide row crops. It cannot be used for the rice because it requires some row to row spacing, more row to row spacing. Okay. Next. So this is post-over digger. This we introduced in 1986. This can be used for the new orchards is to be planted. For the new orchards, if you are planting new these plants of orchards, apple or whatever the plant you want to plant. So for that, this to put that hole in the field. So this machine can be used. This is tractor operated as well as manual operated also there. Okay. So this can also be used. Next. Yeah, this data is clear, I think. Previous one. Go Number of manufacturers for this are 5 in Punjab, and number of machines are hundreds, also some older data. So number of machines now in thousands there in Punjab, and annual production is over 20. Next. This machine is very popular now in our region, in northern part of India, in Punjab, in Haryana, in UP. This you have heard the name of this machine? Laser land leveler.
Yes.
You have heard this? Okay. So this is basically used for the fine leveling of the field. I have seen when I was traveling yesterday, so here fields are not leveled. You have not, you can say, done anything, any to level that field. Whatever the topography of the field is there, this is as it is. This is good, although this is good. We have not to disturb that our fields. But here in our Punjab or in that parts, we have disturbed whole of the field by using these levelers and now these laser land levelers. Okay, so this is very popular now. This is used for the fine leveling of the field because we are taking this rice crop in a whole of this Punjab. So for that there is water requirement is more, that water guzzling crop, that rice is there. So that's why we are leveling our fields by using this machine, so that there is saving of the water in the range of 25 to 30% water saving. Okay, so that's why we are using these machines. You can see how these machines are, we have introduced in 2005-06, and now in 2019-20, these machines are about 12,000 machines are operational. So big number of machines, those are operational in Punjab, and this data is that we have almost 3/4 area of Punjab we have already laser leveled. So in that big way this machine is being used. Okay, so next. That machine was basically based upon the laser principle, as laser technique is used for the leveling. So this machine is based upon GPS signal or GNSS signal. So because in India we have still accuracy is not up to the mark, or not much accuracy in the signal of GPS or GNSS is there. So but some machines are operational, or this technology is there on the basis of this GPS or GNSS. So this is better technique, because in earlier machine, laser based machines, we have to first have that survey have to be done, and then put that reading to the machine, and then that machine is used. But in this there is no need of that survey, directly we can use this machine. So as you know that the GPS is given 3 types of data, this latitude, longitude and altitude. So this machine is based upon the altitude of that GPS signal. Okay, but accuracy is required. This machine is also now very popular, going to be very popular, that is pneumatic planter. This is based upon the suction principle. The seeds are sucked, each single seeds are sucked from that hopper or from that seed box, and then single seed is to be sown in the field very, you can say precisely, or with the principle of pneumatic principle. That's why this is called pneumatic machine. And some say that this is precision machine. This can be used for the bolder seeds as well as for the smaller seeds. Bolder seeds means that is of the maize, that is of the cotton, so or sunflower, so those are bolder seeds. And smaller seeds means here we use for the mustard. Mustard is very small. I think if you have seen, mustard seed is very small. Here you are growing, I think, many small seeds. Can you give any example?
So small seeds, very brassicaceae family, like Norcol is there, turnip is there, in horticulture crops, and also mustard is also grown there.
Okay, mustard. So then this machine can also be tried here. And one saffron is also cultivated here. Na? So how you cultivate seeds so that saffron?
Palms, there are palms.
There are palms.
Yes.
So seed is smaller, but size of
The
seed.
comb is used mainly for propagation. I don't know about seeds. there is no concept of using seeds in saffron.
Com means what do you mean by com?
Planting material.
Okay. So that root or anything,
Modified
root or maybe stem or
Stem.
something.
Modified.
So that is used for the saffron soil. Okay. So next. This is now recently introduced this machine. So this is direct sowing of rice with automatic spraying system. Here I think in the rice you transplant vertically manually. So we also saw that transplanting manually, but machines are also there. Kubota from the Japanese machines are also there. So but they require this wash root type nursery, specialized nursery for the planting or transplanting of the rice. But this machine
we are
is
introducing that transplanting system here, machine.
okay. You have in your department that machine. Okay. So this machine is for the direct sowing. There is no need of transplanting. Directly this rice seed can be sown by using this machine. So this is a recent development, and also spraying system is attached because this with the rice planting there is need of spray of weedicide. So this spraying system can be used directly for the spraying of the weedicide or herbicide. Okay. Next. Yes, these two machines are now being used in some area, have been transplanted by using these machines. One is riding type on which person is sitting and then controlling all of this machine, and the bottom one is that person is walking behind the machine. So these two type of machines are popular. So this is for the direct transplanting, as this machine needs wash root type nursery. This mat type nursery, not wash root. Sorry, mat type nursery, but that is specialized nursery. So that type of nursery is used by this machine. Okay. Next. Recently this machine is also developed by our department. This is mat type nursery seeder, because this specialized nursery, mat type nursery seeder, earlier was sown manually. All the operations like this, first making the bed, then polythene, this spreading, and then spreading the seeds, and then again spreading the soil, then putting water on it. So all these were done manually, these operations. But now this machine can do all these operations in one go by this machine. So this machine, we have also applied patent of this machine. This is doing all the operations all in a one go. Okay. So this is a new machine. Next. This is showing that how this looks, this mat type nursery, by using manually or by using this machine. So these are just comparison of this. Next. Yes, next is spraying. So although we are using this spray machine for the cotton, but this can be used here for your maize crop, or not for this, you can say, horticulture crop. But because these guns are at this place, but you can hold this gun like this. These guns, you can say boom can be put like this, because our boom is horizontal, so you can put that boom in vertical. So then this gun will be here and this will do spraying like this. So this can be tried here also. Okay. Next. This we are also using for the cotton crop. The high clearance tractor is there because cotton crop is having very good canopy or high growth canopy. So this high tractor has been done high clearance, and then boom type sprayer is putting at the front of this, and this spraying is done on top of the crop as well as at the bottom of the crop. So this is high clearance sprayer. This you can't try here. Next. Yes, this added this slide I added today morning because you don't have here thresher also.
Yes, sir.
Because this I have seen yesterday that persons were handling that bundle of the rice crop, and then they putting on some structure, and they were doing harvesting of the crop. So this threshers can be tried here first, because manually cut and then threshing can be done by using this thresher machine. This is multi-crop. You can try it for rice, you can try it for maize, and you can try it for oilseed also, any mustard or whatever here. But for the saffron or other things, then some modifications will be required. That cylinder and then concave. So this thing we have to change, and then this can be tried. Okay. Next. Yes, combines. You don't have here combines, but we have now 100% or 99% area is harvested by using these combines. But as this first stage is that if this is done manually, and then threshing is can be done by using thresher. But directly you can use combine also, as if there are pockets of the area that in that pockets this can be tried combines because this is manually, there is no need of the manually harvesting as well as threshing, so it is doing all the operations in the one go. Okay. So this can also be tried. Yes, new thing we have added in this, that is super SMS. At the last, at the rear of this, there is super SMS. Super SMS means super straw management system. So what it's doing, as from the rear there is this material that is coming, straw material is coming out of this. So that is of the longer size, and then after because farmers were burning that. So to avoid that burning, we put this super SMS at the rear of the combine, so that that straw can be cut into pieces and spreaded in the field, so that this cannot be burned. Directly drills or other machines can be used for the management of the straw. So this super SMS new attachment. Next. Yes, these are advantage of this: uniform spreading of paddy straw size reduction up to 50%. So this is because to in situ paddy straw management, field capacity increase of happy seeder. So these are cost and the advantage. So this can also be used here. Next. Yes, this happy seeder. Because you are taking only one crop, rice. After rice, there is no crop. So I think you don't need this machine. But because we are using, we have to sow wheat after the rice. So then directly, if we want to directly sow that wheat crop under rice straw, so this machine is used. And you can see here that within the rice harvested field, directly this can be used for the wheat sow. Happy seeder machine. This is also new machine. Next. And yes, this you can try here. This is automatic sensor or filler based offset rotavator. Rotavator you know, I think. So rotavator is basically for the cultivation or for the tillage. So this is at the rear of the tractor, and this is doing fine tilling of the soil. So, but this is offset. Offset means, because if we are using for the orchards, so in orchards between tree to tree, that place is not tilled now. So now this is offset. So this is moving within the tree to tree. And when any tree is coming, so there is one sensor or feeler, when it touches with the tree, so it moves that rotavator in this position, so that it will not hit that tree. So then slowly this will come again, tilling that or leaving that place, that tree, and again it will come when there is tree to tree spaces there. Okay. So this machine can be tried here. Next. This machine also can be used, but this is imported version of machines. This is used for the pruning, for the horizontal pruning of the trees, as well as for the vertical pruning. So this is very good machine for here in your case, for the, because you have many orchards, so this machine can be used. Next. Yes, this machine recently we developed. This is tractor operated tree shaker. So for the because here I think I have heard from Dr. Muzamil that someone has tried that robotic arm for the picking of the fruits or picking of the apples, and that is not I think its performance is not satisfactory. But this you can try here. So this is tree shaker basically. when this whole of the these apples or any fruit is ripened, so then machine can come and then pick this tree. Yeah, so and then it will shake this, and all of these fruits can fall down on the umbrella. So this umbrella you can see here. So this machine can be tried here also. Next. This we have used for the amla, you know, amla, and also for the jamun. So we tried this machine for those two fruits. Next. Yes, these are in the operation. So this is something about mechanization part, and next part is sensor or automation. So that we'll discuss. But before moving further, you can take tea and we can just discuss for 5 minutes that any your feedback or any your question regarding this farm mechanization. So then we will move further. So any question or any feedback, anything?
So, you mentioned about pruning machine. How does that know which branch they have to cut? They have to prune.
Pruning.
Yes. How do you know?
So there are discs. There are discs. So discs are in vertical discs are also there, and they can be moved. The disc can be moved like this, means horizontally. Then they cut horizontally. So basically, moving of those discs, and discs are serrated one, and these are operated by hydraulic system of the tractor. So power to move that, there are hydraulic motors are there. So those hydraulic motors are operated by the hydraulic system of the tractor. So that movement of those discs are used for. Any other question? Pardon? Shaker. Damage it depends on fruit to fruit. Because we have tried for amla as well as for the jamun. So this, although this amla fruit is very tough fruit, but its injury is, if there is small injury, so its market value is very much reduced. So there was in the range of, you can say, 6 to 7%. 6 to 7% loss or injury or whatever you can see. So this was there. Any other?
Sir, you told about the shaker machine. Sir, according to me, it doesn't damage the roots when we shake the tree. It doesn't affect the roots of the plant.
Yes. Because this is area of research. I think that damage is not there. Means they are damaging the whole fruit. Yeah, maybe some roots might be weakened. This is area of that research. We have not taken any data for that, but this is a very good point. That this data is also important. कोई आपका क्वेश्चन? फार्म मशीनरी के कौन कौन है? फार्म मशीनरी एक तो मुझे दिखे. Farm, who is from farm machinery? You are from farm machinery? Any other? Farm machinery side? Only one. फील्ड्स हैं, ये मैं नहीं है आज तक किया।
सर आपने प्रूनिंग मशीन का बोला था ना, वो हम कैसे सेंस कर सकते हैं कि वहाँ पे प्रूनिंग करनी है, मतलब किस पॉइंट पे काट मारना है, वो उसमें कोई सेंसिंग सिस्टम होता है?
नहीं, सेंसिंग सिस्टम नहीं है कोई, दैट इज प्योरली मैकेनिकल सिस्टम। सो वो तो आपको हॉर्टिकल्चर वाला कोई साइंटिस्ट बताएगा। आप किस फील्ड से हैं?
प्रोसेसिंग एंड फूड
प्रोसेसिंग एंड फूड इंजीनियरिंग। तो हॉर्टिकल्चर का कोई होगा इसमें, हॉर्टिकल्चर वाला वो बताएगा कि कहाँ से प्रूनिंग करना है
Food
इसका।
sciences.
फ्रूट साइंसेस का जो हॉर्टिकल्चर वाला जो स्पेशली फ्रूट साइंसेस, ठीक है। तो हॉर्टिकल्चर में तो वो वेजिटेबल भी आ जाएगा, फ्लावर भी आ जाएगा। तो फ्रूट साइंटिस्ट जो है उस मशीन पे जो काम करता है, उस फ्रूट पे जो काम करता है, एप्पल वाला मान लो, तो वो बताएगा कि इसकी प्रूनिंग कब करनी है, कहाँ से करनी है, कौन सी प्रूनिंग कहाँ से काटनी है। तो मशीन तो वो फिर वहाँ से आपको ऑपरेटर जो है वहाँ से बता देगा। So, any other question? No question? So then we will proceed. Okay. So then, as mechanization part is, you want to talk something? Or it's okay. You have to start. So now, as we have discussed, first animate farming, then mechanized farming, then third precision farming. So animate farming, you are doing that, enjoying that type of farming, and now you have to shift to the mechanized farming. As in Punjab, we have crossed, we have fully mechanized. Many things we have mechanized, but some parts like cotton picking is not mechanized, orchard harvesting is not mechanized, sugarcane harvesting is not mechanized. So in these areas, we still need mechanization. Now we are thinking of that precision farming or digital farming or automation farming. So that we will discuss what we are doing in our university. Okay. So first we will discuss what is the need of that. As in Punjab or in similar states, we are using blanket and uneven application of inputs, like example is use of NPK in the ratio of 18:6:1, but requirement is 4:2:1. Optimized is 4:2:1, but we are using 18:6:1. So it means we are using more nitrogen. So that nitrogen is polluting our water system. This is degradation to the environment, and also we are not using much more phosphorus and potassium which is required. So in that way, example is that we are using these fertilizers in a blanket way or uneven. Okay. So that's why precision agriculture is required. Next, depletion of water resources. So this is as for the, especially for the rice crop, we are continuously pumping water from the ground. So this in that, if we are continuously pumping water from the ground and recharging is very less because rain water or rain, not much rain is there. So that's why this groundwater table is going down and down. So now more than half area of the Punjab is under red zone. Red zone means where there is more harvesting of the crop but lesser recharging. Okay, so that's why you need precision farming. Then more environmental pollution because of increased use of chemicals. We are using again these chemicals and spraying in a big way. So this is creating environmental pollution. And also burning straw, rice straw especially. So as first now we have introduced this super SMS in the combine so that they cannot burn that straw. They can mix that straw in the field, in the soil. So this is third reason. And low productivity of crops. This is for the Indian situation. In Punjab we are at the better position, but this is 30 to 50% below the international average. If we compared of these China, these Australia, the USA, so then 30 to 50% below that average. Okay, for the India. In Punjab we are at the better position. High growth of population. This you know, this is faster than its ability to produce rice and wheat. Very high post-harvest losses, 25 to 30% in the range of that. and only 10% of produce is processed in the country as against 40 to 60% in other South Asian countries. So this processing is also little bit, not much processing is done, and nutritional insecurity of rural population, because we are ignoring quality of the produce, quality of the product. We are only concentrating how much is the yield, how much is the produce. We are ignoring that quality as well as environment. Okay. So all these reasons now dictate that we have to proceed or we have to move from mechanized farming to precision farming. Next. Yes, this because artificial intelligence is a word or is a buzzword in this. This is what is that artificial intelligence? You know what is artificial intelligence? In your terms, what is artificial intelligence? As there is human intelligence, or you can say natural intelligence, but this is artificial intelligence. So what is that? क्या समझते हो आप क्या है artificial intelligence?
Use of sensors,
Use of sensors.
certain commands to assign tasks, to perform some tasks by use of sensors.
Okay. Any other?
Decision-making capabilities of a machine.
Pardon?
Decision-making capabilities.
Decision making capacity of the machines. Okay.
Simulation of human being.
Huh?
Simulation of human being.
Simulation of human being. Okay. Okay. So yes, these are two words in artificial intelligence. So this for one of the good example of this is self-driving car. So now these cars are available in USA. There is no human or operator or driver is operating those machines. But because in a rush, in a cities, it's very difficult to move that car in that rush. So because there is no human intelligence is there. Only machines or computers, those computers or those machines are using or trying driving these machines in a rush field or in a rush roads. So that is a good example of the artificial intelligence. But in agriculture, this can also be tried as autonomous tractor. So I have seen in China, so they are using now autonomous tractor. They are calling it slave tractor. Means there is only one driver that is sitting on the tractor, and 4 or 5 tractors, those are following that tractors. Only one driver is moving 5 or 6 tractors. So they are in that command, or slave tractors. So in that way, this artificial intelligence can also be used for the autonomous tractor. Okay. So these are some examples like drones. Here you have drone in your department.
Yes.
You have drone. So for which purpose you are using?
So spraying.
Spraying purpose. Okay. So that drones are also because this is remote control drones. So person is sitting at the end of this, and these drones can be operated. This is also an example of artificial intelligence. Then these robots, facial recognition. So these are examples of this. Now there are some elements of artificial intelligence like machine learning, neural networks, natural language processing, vision, robotics, expert systems, speech interpretations. All these are elements of artificial intelligence. Okay. Next. So yeah, this is comparison of human intelligence as well as artificial intelligence. So because there is computer, so this earlier there was personal computer, now there are supercomputer. So if we compare with this supercomputer or personal computer with the brain, so this computational power of this is as in supercomputer, this is 10 raised to power 4 CPUs and 10 raised to power 12 transistors are there. In personal computer, there are 4 CPUs and 10 raised to power 9 transistors. But in our brain, what's that? 10 raised to power 11 neurons. So it means neurons and transistors. This is the example. This is the comparison. In human, this is neurons, and in personal computer, there are transistors. Okay. Then storage capacity for the supercomputer 10 raised to the power 12 RAM, 14 RAM, in personal 10 raised to the power 11, and then brain 10 raised to the power 11 neurons. Cycle time, so there is a difference, big difference of cycle time. In cycle time of supercomputer, this is 10 raised to the power minus 9 second, only 10 raised to the power minus 9 second. Personal computer same, but in our brain that capacity is lesser. So this is 10 raised to the power minus 3 second. So then operations 10 raised to the power 15, 10 raised to the power 10, and in brain it's 10 raised to the power 17. And then memory, this is almost same, 10 raised to the power 14 updates per second. In case of personal, this is 10 raised to the power 10. In our brain, 10 raised to the power 14. So this is the comparison of the human intelligence with the brain, or with the artificial intelligence. Next. Oh yes, so these are some jobs in agriculture. So there are some routine jobs, there are some non-routine jobs, there are manual jobs, and there are cognitive jobs. So these are examples are there. As the routine manual is manual bulk harvesting. As in your case, your farmers are doing bulk harvesting of the rice crop. So there is no need of that an intelligence or anything. Only that is a manual as a routine job. Okay. So this is the example of that. And then manual and non-routine. So that is machinery driving. Any agriculture machine or tractor driving, that is manual, but that is non-routine. And the difficult example is cognitive and non-routine. That is disease detection in any crop. So we now this is the area of research. In all advanced countries, this type of research is going on. That how we can predict the disease in earlier. That disease is coming to the crop. If we can detect earlier detection of that disease, so that will be more useful. Otherwise, what will happen if disease is there? We have to just spray, only spray. So that is again creating pollution, or that is not a better way. So better way is that if we can do the earlier detection of disease. So that comes under cognitive and non-routine. Okay. So here this our precision farming or artificial intelligence is required. Next. This is what is the importance of data? So how we can do precision farming? So but before precision farming we have to have the data. Data is very important. So this is said that what gets measured get managed. So which is measured, which can be measured, that can be managed now. Otherwise it's not possible. So first we have to collect the data. So that measurement will give data. As Google Earth demonstrates spatial data as commodity like oil and gold. So this will be as important as this commodity or oil commodity. So this data is very much important in agriculture now. So what this data will give? Data analysis will give information or knowledge. And then what will knowledge give? Knowledge will provide intelligence. And then intelligence will lead towards wisdom. So this is basically Japanese philosophy. So they say that first we have to collect the data, and then slowly we will get that wisdom. Okay, next. In a nutshell, what is precision agriculture? So this is basically better input management. What we are giving inputs, so that better management is precision agriculture. So what are those 5 hours? So this is given by 5 plus 1 hour. There are 6 hours are there. So what are those 5 hours? Yes, next. 5 plus 1 hour, yeah, next. So first input is, first hour is right input. Inputs are many as chemicals, fertilizer, water, machinery, labor, all these inputs. We have discussed that. So, but right input, selection of right input is first hour of the precision agriculture. So I have given one example, that ulala. Ulala is one chemical that is used in a cotton crop for the management of whitefly. Okay, so that we have to select first right input, that is first hour. Next, right amount. हमने अब select कर लिया right input. Now we have to decide that how much amount or dose is to be sprayed. For that ulala, that 80 gram per acre is the right amount or dose. That is second R. Okay. Third R, right time. Apply कब करना है उसको, डालना कब है स्प्रे को. So that is above ETL. ETL, you know, ETL? Economic threshold level. So economic threshold level is when 6 to 8 numbers per leaf. So then we have to apply that. That is the right time. Third R. Next. Fourth R is right place. डालना कहाँ है उसको? That is middle of canopy and underside of, because वो जो white fly है, that resides at the underside of leaves or at the bottom of the canopy. So वहाँ पे डालना है उसको. So right place क्या है उसको डालने का? That is right or fourth R, right place. Last, right manner. How we have to apply? Nozzle कौन सा use करना है? Engineering कहाँ है? Farm machinery के nozzles वो farm machinery engineer बताएगा ना कहाँ डालना है या कैसे डालना है. So that is right manner. उसका सही ढंग क्या है डालने का? So that is fifth R. Next. Right genetics. It's also very important. Recently, this is world standard language of the precision agriculture. So recently, this sixth R has been added. That what is the right genetics or what is the right material or what is the right seed or variety. पहले वो ही नहीं सही होगा तो फिर जो पांचों जो मर्जी डालते रहो. ठीक है. So first R is or now this is added sixth R, that is right genetics. And then all other are better input management. So right input, right amount, right time, ये कौन बताएगा? Entomologist, agronomist और plant pathologist. And right place कौन बताएगा? ये भी agronomist बताएगा. And right manner कौन बताएगा? ये engineer बताएगा कि डालना कैसे, machine कौन सी use करनी है, nozzle कौन सी use करनी है. So it means precision agriculture is basically a multidisciplinary field. It's not a task of an engineer or entomologist or agronomist or horticulturist. So this is a multicultural or multidisciplinary this area of research, that is precision agriculture. Okay. Next. Yes, this is application of AI in agriculture. So artificial intelligence की agriculture में कहाँ हो सकती है? Crop yield prediction, intelligent spraying में, then predictive insights, agriculture robots. This we have discussed. I think crop and soil monitoring, disease diagnosis. Okay, next. Yeah, this is that how much agriculture and artificial intelligence is important in agriculture. In 2017, the global market for artificial intelligence in agriculture was US $545 million. So now in 2024, this will be $2,000 million. So this is good potential of this, and market value is rising at the rate of 21% annually. The growth is 21%. Next. This is how this artificial intelligence in which areas that were used. As in, you can see that in crop area it's mainly using, and then also some livestock and soil and water. And in this crop, this is again for the disease detection, for the weed detection, for crop quality, species recognition. So in that way, this is given that how this is being used in agriculture. Okay, next. Yes, so this is that what are the platforms where this can be used. For the sensors are there. Platform is it is to be added on the tractor or on the drone or on the satellite. So those are platforms. Then this data is collected. Software are there. Data is collected. Then artificial intelligence or that you can say analysis. That decision is taken. Those decisions are given to the implements, and then actuation is there. So in that way, this is how this can be used. Next. This is types of data. So soil survey data is there, crop yield data, elevation data, electrical conductivity of the soil, many parameters of the soil are there. Then satellite images, aerial images, machine information like fuel use, engine load, RPM, field scouting, pest. So this is in a nutshell. There will be a huge data. So that data is called, what is called that? There is one term for this, big data. So why this is called big data? Because big data means there is number of datas are there. So then if number of datas are there, so that we have to analyze and get some information or some wisdom for that, and by using that data mining. So that is called data mining. Next. Yes, this is agronomic data. This is now is a view of field view of satellite view of that field. Different colors means there is different type of this yield data is there. So if there is you can see if there is that red data, so this is yield is in the range of 450 bushels or pounds, sorry, pounds. And when there is green data, so it's lesser yield is there. So this is in a nutshell that yield data when seen from the satellite of any field. Next. Machine data, as we have discussed, the engine, how much is the engine load, how much is the oil pressure, how much is the fuel rate, engine torque, engine speed. So this is whole machine data. Next. This is view of NDVI image of cornfield, remotely sensed. NDVI, you know? NDVI. What is NDVI? You don't know NDVI. So this is its full form is normalized differential vegetation index basically. So this gives NDVI value gives that how much is the chlorophyll content of any crop. So chlorophyll से क्या मिलेगा? What is chlorophyll content will give that how much is the nitrogen in that crop or in the leaves. So NDVI directly gives the data of the nitrogen content in the leaves. So उससे हम ये कर सकते हैं NDVI जहाँ पे ज़्यादा होगा, it means there is sufficient nitrogen is there. So now we have to apply less nitrogen. So in that way this NDVI is very important. So this is NDVI data of that. Next. This is multi-year yield maps. Means yield data is also important to start the precision agriculture. Yield data की importance क्या है कि हमें जब पता ही नहीं चलेगा कि कहाँ पे yield कम है, कहाँ पे ज़्यादा है, तो हम precision farming कैसे करेंगे? So first basic you can say start of the precision farming is on the yield data. So first we have to get the yield data of that field and then we can start our precision farming. कि कहाँ पे precision farming की जरूरत है. If yield data is same, there is no need of precision farming. It means variability in the yield data basically governs the need of the precision agriculture. Okay. Next. So yes, big data we have discussed. What is big data? So the big data is that have scale, that has diversity, that has complexity. So this is a definition of that. And then many algorithms and analytics to manage it and extract value that is hidden in that. And this can be done by using cloud computing, wireless connectivity, sensor, consumer device. So these are all this which are the source of to collect the data. Okay. Next. Data mining, we have discussed the data mining. Data is gold and information is extracted from that way. And here it is also given that one agency in the international agency or world over agency, that is AG Gateway. So that is basically giving the standards for the data transfer or data transmission. So or communication, data transfer and communication. So वो एक standard बना रहे हैं world level पे ताकि जो क्योंकि different gadgets हैं, different sensors हैं, तो उनकी आपस में जब डाटा की communication नहीं होगी तो वो कैसे डाटा communicate होगा? So वो एक standard बना रहे हैं, ये जो AG Gateway that agency is making that standards in that for the data transmission and data transfer or data communication. As earlier we have discussed that yield is very important. So we started this working in our university to collect the yield for the grain crops because in Punjab we have that wheat and rice main crops. So we have combines for the harvesting of the wheat as well as for the rice. So we put this yield monitoring system on the combines or yield sensor you can say on the combines. So this yield monitoring system is having GPS system with that. So GPS system means that location is coming on that for each location of the field how much is the yield of the crop. So in that way this we have mounted on the combines. Next. These are two types. In word over these two types of monitoring systems are there, batch type and one is continuous type. So first we tried batch type. So those batch type are not you can say successful or satisfactory for the collection of the data. So then we tried this continuous type. So next. Yes, this is continuous type. First try this type of sensor system or yield monitoring system on the combine. As you can see, grain tank is there on the combine. So on the bottom of this grain tank, we put load cell. At the bottom of the grain tank, you can see that load cells are mounted, and then the data of that load cells are coming to the microcontroller and then display unit. Similarly, this inductive sensor which we put on the rear wheels of the combine. So that is basically giving that how much area is to be harvested, because this moving of, or this you can say rotation of the wheel is giving this how much distance is covered, and then multiplied with the width of the combine. So this will give area covered by the combine. So that area, and then load cell is giving data, that yield data of that, or you can say mass of that grains. That mass is divided by that area. So this will give yield. How much is the yield in that particular field? Okay. So in that way, this we tried. Next. Then this previous one. In this, you can see that this load cell is put on the one auxiliary tank. That auxiliary tank was put in the main tank, and then load cell was in that. So problem in this was that when this auxiliary tank was filled, so then we have to remove all these or empty those grains from that auxiliary tank. So this capacity of the combine was reduced in this way. So then again we tried that another one, next one. Yeah, so this is optical sensor, master sensor, junction box, GPS, all these were components of these yield monitoring system. Next. Yes, so this optical sensor we put in that elevator. So when grains were moving from the from that bottom to the tank, so then these optical sensor was measuring basically the height of the or depth of that grains. So from that height we can calculate that how much is the volume of that grains. Then it was multiplied with the density of the grains. So that data is basically yield or that mass or that weight of the grains. So in that way, on this principle, this system was working. So next, yes. So you can see here that these conveyors, that sensors are put, optical sensors, and then there's some calibration is required for that, and then this can be used as a yield data is calculated from that. Next. Yes, from this you can, this is concept of that photoelectric yield sensor. Volumetric flow is height, and then elevation, elevator speed, then some calibration required, then mass flow is coming with the volume of that into grain density. So in that way this is used as the yield data of that plot. So this was combined in our department, so we tried putting on this sensor on this combine, and then this was used for the yield monitoring system. Next. There was also a moisture sensor that was put also at the bottom of that conveyor, so that if moisture data is also required, only otherwise if moisture data is not there, so then we can't comparison that for which moisture that crop was harvested. Next. Yes, next, now recently we tried this autonomous walk behind type paddy transplanter. As we were discussing that there are autonomous tractor in the countries, in some countries. So we put this autonomous system on the paddy transplanter, because this paddy transplanter was basically walk behind type paddy transplanter. And in such in the month of you can say June, July, there is a lot of humidity, and then there is a high temperature. So it's very difficult to work with that operator, also operating the machine in that humid and its hot temperature. So we removed that person, and he is standing in the shade of the tree and operating this paddy transplanter. So this is autonomous type paddy transplanter. Next. This is another thing we are evaluating, this satellite navigator. So this satellite navigator is basically for the efficient operation of the tractor. Not autonomous tractor. We can't make autonomous tractor here in Indian situation because we can't replace labor. But we can help the labor or operator. So this is basically guiding to the operator, and the screen is in front of the operator, and the screen is guiding that you have to operate this machine in a parallel or in a straight way. You have not to any miss or anything, any spraying or anything, whatever operation we are doing. So there should not be any missing or there should not be any overlapping. To reduce that missing and overlapping, this system satellite navigator is basically helping that operator. Okay. This is now data acquisition system for the monitoring of tractor performance. So there are many parameters which has to be detected for the efficient operation of the tractor. Slip is very important parameter. Draft, then fuel consumption, radiator fan speed, engine speed, forward speed, geolocation, angular inclination of implement attach. All these are important parameters for the operation of the tractor or testing of the tractor. So these are many sensors are mounted on this tractor to detect all these parameters. Okay. Next. Yes, this is one small sensor that is used for the measurement of the soil organic carbon. So basically this was developed by IIT Kanpur. We procured this sensor for the measurement of organic carbon because now there is a work going on carbon credits. Carbon credits that farmers are doing these precision farming or this conservation farming. So how much they are putting that carbon or organic carbon in their soil. So to measure that organic carbon or for the carbon measurement of that carbon credits. So this soil organic carbon we tried. Although this we have done for 200 samples from the farmers field done by using this sensor as well as the laboratory analysis. So we were just comparing those values that how much accurate this sensor is. So its reliability is not, you can say, fully satisfactory, but 70-80% data was okay for this. Yes, so we also tried this for the measurement of carbon dioxide and methane in the field, because in the rice field there is a lot of methane is generated because this is submerged field. So to measurement of that carbon dioxide and methane in the field, so we developed this sensing system. These two sensors, one K30 for the carbon dioxide and MQ4 for the methane prediction. So this is put in the one box and then this was installed in the field. Next. Yes, so this is installation of this sensor and also validation with GC analyzer. So there is GC analyzer are there. Soil people might be knowing that they have in their labs that GC analyzer. So we are comparing this sensing system for the carbon dioxide and methane with the GC analyzer. Next. Yes, then this tractor operated real-time soil pH mapper. This was done by one of MTech student. So this machine is this traditional machine for the bund making. This tractor operated machine is there. So he put one soil pH sensor in that machine and measured this real-time data of the soil pH attached with this tractor. Next. So these are maps generated. Different color means there is different pH of the soil. So this is 4 fields he tried for this and then generated the maps. Next. But future is, because there are many sensors are available for measuring of single parameter. Soil compaction parameter is measured by this sensor. Then soil EC sensor is there. Soil pH mapper we developed. But future is that in a one machine there should be mounted all the sensors and then real-time sensing of all the parameters of the soil by one go of the tractor. So this is called soil sensor fusion. Means all the sensors should be mounted on one machine. Next. Yes, so this will be a multi-sensor platform for the measurement of soil EC, for the compaction, for the pH, or for many parameters. Next. Yes, so there is another, recently one of my student, PhD student, he is working on this idea because we have discussed that this paddy transplanter, they need specialized nursery, that is mat type nursery. So farmers are reluctant to raise that type of nursery because this nursery growing is also a very cumbersome procedure is there. Although we developed one machine for that, but farmers are not still adopting. So now we are trying that if any transplanter that can be used for the wash root type nursery, means farmers are growing only that wash root type. They have that bundle, labor is putting one nursery or one seedling in that. So now robotic type transplanter we are trying for the as washroom type nurseries in the tray, and that robotic arm is pick one or two seedlings and then transplant in the plant. So in that way we are trying this next. Yeah, this is some video of that. Speed is slow, but we have just started this project. Okay, next. Time is there, or what?
The 5.
5 just. So this we put this robotic arm on this machine, and then we also try it in the field also. Next. So this is leaf color chart. This is recommended by the university. Very simple device or low cost device for the nitrogen application or for the urea application. This you have seen here? Is your university or?
Yes, sir. Yes, sir.
Okay. Next. So these are some 4 or 5 sensors which are used for the urea application or nitrogen application. One is small sensor chlorophyll meter or spread meter, then optical end tester, green seeker you might be having in your university also. This one we procured from the Germany as put in front of the tractor. This sensor, this blue one. So this generates this map of nitrogen or urea, that how much urea is to be applied. Next. So this because that sensors may be green seeker or maybe there's nitrogen sensor used for the mapping of the field, and then we are developing this variable rate applicator for the application of the fertilizer. That signal is given to this machine, and the machine is applying urea or fertilizer based on that data, sensor data.
So what was the cost of the nitrogen?
Oh, it's costly, 10 lakhs. So drone you are also having here. So we which company you have here? Drone.
So one of the scientists is working on that.
Okay. So this we procured from one manufacturer in the Delhi. So these are specification hexaquarter type, maximum speed, maximum flight. Almost these are similar in whatever available in India. All these.
Sir, we are having a 16-liter capacity.
16.
Yes.
Okay. So this is having 10.
10 liters.
10 liters. Next. This is there is one project in which we are measuring all the soil EC, pH, NPK, moisture, and then weed identification by using drone, multispectral images we are collecting for the field, for the crops as well as for the weeds, and then weed detection, and then rice. So these are R&D areas. Next. Yes, this is variable rate applicator for the fertilizer in the drone. Similarly, as we are trying variable rate applicator for the tractor, similarly variable rate applicator for the drone spray. So this we are also trying. These are fertilizer for the foliar spray. Next. This is our just recommendation. First recommendation on the drone that these flat fan or anti-drift air induction nozzle can be used at a pressure of 1.38 kg per centimeter square, forward speed of 2 to 3 meters per second, height from the crop 2 to 3 meters. So this is first recommendation from the university side. Next. Then we calculate cost. What is the cost coming on? So this is 745 rupees per hectare is cost coming on the drone spray. So now because some these custom hiring centers are also using or operating this drone on the custom hiring basis. So then we calculated this cost, and now they are based on this cost they are charging from the farmers. having their profit also 20, 15 or 20% margin or profit. Now they are using this drone on the custom hire basis. Next. This is not our, this is one CDAC, this you can say one machine they are using for the tea quality detection. So this is also AI example you can say. Next. Grape disease detection system. This is also based upon machine learning. Different sensors are used for the grape disease, earlier detection of the disease on the crops. So next. Yes, virtual fencing. This is Australian picture. So they are using this for the managing of their herds, their animals, for the virtual fencing. So one collar is put in that, and then now they put one area that the animals cannot go beyond that fencing. So that they call it virtual fencing. So this is Australian farmers are using. Yeah, these maps, apps, mobile apps. So these 5th, 6th and 7th are by our university for the farm machinery, for the late blight detection, for the seed portal, and other the top 4, these are very popular apps which you can also try for your crops. These are free apps, and this like One Soil app, EUS crop monitoring app, Zarvio scouting, Plantix app. So all these are good apps. This can be tried in a free way to start the precision agriculture in any region. Next. Yeah, so that's all. So these are future forms, small and smart. So this is just imagine. So that's all. If you have any question or any discussion, any feedback, so that we can discuss quickly.
Sir, what is the cost of that remote operated paddy planter?
Remote operated paddy planter cost, because cost on the paddy that manual one is 3.5 lakhs approximately, but without autonomous. So if we add that autonomous system on that, so you can add 1 or 1.5 lakhs. So means about 5 lakhs.
And sir, all those tools in implement plus sensors.
एक मिनट आ रहे हैं वेट कर नहीं अंदर ही आ जाओ ना नहीं अंदर ही आ जाओ ना यूनिवर्सिटी हाँ हाँ आ जाओ
So you please interact.
So all those tools and implements plus those sensors, the small ones, not the big ones, sir. If I want to set a shop for that, what is the success rate, and is there any subsidy by the government, or please tell about that?
Because these sensors or these machines, Manjeet, क्या हाल है? So all these sensors or automation which we have discussed, so these are R&D, in R&D phase, not commercial one. So commercial is only drone, you can say. Drone application is commercial, but other things are R&D phase, or we are doing in the university.
So when it will be commercialized?
Pardon?
When it will be commercialized?
Commercialized, okay. So this depends on that soil sensor, as because soil sensors are very low cost. So these can be commercialized in the near future. But other machines, those are costlier, and they need some because now some sensors or some technologies are imported one. So when these will be manufactured in India or in our region, so then this will be commercialized. So it will take, you can say in a nutshell, in next 4 to 5 years, these all can be commercialized.
Sir, soil pH के जो maps बनाए वो किस software से बनाए?
Yes sir?
Soil pH maps
हाँ.
वो किस software से बनाए?
किस क्रॉप के लिए?
Software.
सर वो जो बर्ड फार्मर के साथ आपने पीएच सेंसर लगाया था ना,
हाँ.
आपने सॉफ्टवेयर को यूज किया होगा मैप बनाने के लिए.
Okay.
मैप
Okay. So that map are used ArcGIS. ArcGIS. Any other?
So what is the accuracy of these machines tools, as they are based on AI? So can we as much accurate as compared to human memory or human brain?
Again, it depends on the technology. That if very low cost, so then its accuracy will be, we will compromise that accuracy. So accuracy will be also low. But if we put some cost, add some cost, so then this accuracy will be again improved. So again, it depends on the cost. But as some GPS, the machines which are based on the GPS or GNSS signal, so because in India this GPS signal is also not much accurate, especially altitude data. So longitude, latitude is okay, altitude data is not that accurate. So in that way, that accuracy is still required, that technology, a GPS signal or GNSS signal.
So as we see that in India, majority of the farmers are dependent, majority of the families in population is dependent on agriculture. So if we introduce this system, so can't this be a harm for that labor or economy or in that purpose also? Because agriculture being a very labor intensive.
Yeah, you're right in that way, but that's why when we were discussing, so in India we are not in a situation to replace the driver or operator or laborer. We have to, you can say, facilitate our these operator or driver or our laborer. So in that way, that system, autonomous system are being used in those advanced countries, but we cannot use the autonomous one. We have to, as one satellite navigator we have discussed, so that is basically facilitating the driver to operate or to have efficient use of that tractor or machine. Okay.
You can discuss your research problems. You can get the best suggestion or recommendation. Please. Anyone? Okay, if you are not having any query, then we would like to thank Professor Manjeet for this wonderful session. You know, for a person like me, this lecture was actually a gold mine. I mean, you will not find these kind of concepts anywhere. Read any book, read any website or other relevant data. So thank you very much, sir, for joining us today, and I hope they have learned very much and they will be incorporating all those technologies in their research projects. Thank you very much. I would like to request our head of the division, Professor Jagdeep sir, to give Professor Manjeet sir a certificate and a memento from our side.
Thank you.
Okay, for the information of the audience, Professor Manjeet sir was in the advisory committee when our head of the division, Professor Jagdeep sir, was doing his PhD program. So he came all the way, traveling almost 30-40 kilometers to